Chapter 6, Basic SQL. In this lesson, we'll take a look at the structured query language, data definition, and data types, see how to specify constraints in SQL, see how to perform basic retrieval queries in SQL, take a look at insert, delete, and update statements in SQL, and some additional features. So what is SQL? SQL stands for Structured Query Language. It's considered one of the major reasons for the commercial success of relational databases. The origin of SQL is what's called the relational predicate calculus, called tuple calculus, which was proposed initially as the language square. SQL actually comes from the word SQL, which was the original term used in the paper Sequel to Square by Chamberlain and Boyce. IBM couldn't copyright that term, so they abbreviated to SQL and then copyrighted the term SQL. It's now popularly known as Structured Query Language. SQL is an informal or practical rendering of the relational data model with syntax. So some of the terminology that you'll hear me use in the videos include table, row, and column. And we haven't quite touched on the relational model formally yet, but those are serving as references to the terms relation, tuple, and attribute, which attribute you have heard so far. The create statement, which we looked at last class, is the main SQL command for data definition. And the language has features for lots of different operations, including data definition, manipulation, transaction control, indexing, security specification and revoking, active databases, multimedia, and distributed databases. And we're going to talk about some of these in this class. So here we'll talk about the basic standard SQL syntax. There are different variations that exist in the different management systems out there. The SQL schema, which we've seen the gold star schema, is identified by a schema name. It has an authorization identifier and descriptors for each element. And such elements include the tables, the constraints, the views, domains, and other constructs. And each statement in SQL ends with a semicolon. Here's another example of a create schema statement. We saw one last class. Create schema. A catalog is a named collection of schemas in an SQL environment. And SQL also has the concept of a cluster of catalogs. We use the create table command to specify a new relation, or table. And in it, we'll specify the attributes, their types, and their initial constraints. Now, you've already seen an example of this, but here are some more. Create table company.employee, or simply create table employee. So in the first line, we have the schema specified, but of course, if we've set company as the default schema, then we can simply refer to the table name, create table employee. In the database management system, we have the actual base tables, which are the actual tables, or otherwise known as the relation and its tuples or its records. They're actually created and stored as a file by the database management system. But we can also view virtual relations, which are views. These are created through the create view statement, and these do not correspond to any physical file. The relational model has three basic constraint types that are supported in SQL. The first is the key constraint. There's also the entity integrity constraint that implies that a primary key value can't be null, so it has to have a value if it's marked as a primary key. And then we also have the referential integrity constraint, where the foreign key must have a value that's already present as a primary key, or it may be null. So in the example that we're going to do today, an employee that works at a specific location, if the location ID is stored as a foreign key in the employee table, it already has to be in the location table as a primary key. We have different clauses for specifying these integrity and key constraints in SQL. The first you've seen already, the primary key clause, specifies one or more attributes that make up the primary key of a relation. So for example, dNumber int, which is the data type, primary key. We can also specify an attribute as unique using the unique clause or using the unique checkbox in MySQL. What this will do is indicate that values in a specific field that is not the primary key have to be unique. In other words, we can set a non-primary key field to be unique as well, even though it's not uniquely identifying. We use the foreign key clause to identify an attribute as a foreign key. And what will end up happening is if we try to update a table such that it violates the referential integrity, that update will get rejected. We can also specify other triggered actions, including set null, cascade, and set default, which we might get into a bit later. These would be the same for on delete and on update. So thus far, we've talked about the create schema and the create table statements. Now we're going to look at one of the most common statements that you'll use, and the statement that's used to pull information from the database. So we can conduct what are called the queries. We can ask questions and get answers from the database, like which employees are making more than a certain amount of money, which customers have purchased which products in a certain date range. These are the queries that allow us to see what's going on in a large data set. So here are the basic clauses included in what's called the select statement. When you want to perform a query to get answers from the database, you'll use a select query. Now here are the basic clauses involved. Select from, where, group by, and order by. Now, most of the time you won't have group by and order by. What you will always have is select and from. We'll break each part of this down. So what does the select statement do? The select statement indicates which fields you want to see in your result set. So here we have select first name, last name. What this will do is indicate that we want to see all of the first names and the last names, depending upon what conditions we have. If you need to specify the table name, you can also do that in the select statement by using select table name dot and then the field name. So for example, select employee.name, select employee.location ID. Sometimes you have to specify the table if you're using something like location ID, which is stored in two different tables. The from part indicates which table you're pulling the attributes from. So for example, select first name, last name from employee, or select location ID from employee, or on the last one, select star from employee, which star is a wildcard that would indicate we want to select all of the fields from the employee table. So far we've looked at select, which indicates which fields we want to pull. So first name, last name, or salary, maybe location ID. The from part indicates which table or tables we need to use to get those attributes. The where part is where we can specify different conditions. So for example, we only want to see people whose salary is less than $60,000, or in this case where the first name starts with P or the last name contains a lowercase n, and the salary is less than $60,000. The specific details of this where clause will be covered in a separate practical video, but for now just understand that where specifies the condition that you want to satisfy. So say we only want those with last name Chen, or we only want those whose salary is less than $60,000. If we put all parts of the statement together, we have select last name from employee, where salary is less than $60,000. So if we were to run this statement on the data below, we would end up seeing what? Well, we have last name from this employee table where the salary is less than $60,000. So we would only end up seeing just the last name of this person whose last name is Chen because the salary is less than $60,000. And here, like I said, I tell the undergraduate students, don't forget to wink. That just means that include your semicolon at the end of the statement as well. I strongly recommend going through the video that will discuss specific select statements to see how they work in practice. We also have several statements that can be used to modify the database, including insert, delete, and update. Insert will insert a record or a tuple or a row into the table. Update will change something that's in the table, and delete will delete something from the table. In its simplest form, the insert statement is used to add one or more tuples to a relation, or in other words, to add records to a table in the database. The attribute values should be listed in the same order that they were specified in the create table command. Now, you'll see an example of this in a separate practical video. Constraints on the data types are observed automatically, and any integrity constraints as part of the data definition language specification are enforced. Here's an example of what an insert command looks like you'll see that the relation or the table name is specified, in this case employee, as well as a list of values for the record. So we have the following: insert into employee, values, and then we have a list of values. So because we want to insert values into every single field, we don't have to specify them here, but it is good practice to specify them anyway just to see how it works. Here's another more complicated example that inserts multiple records where a new table is loaded values from the result of a query. The delete statement will take a record out of the table. In other words, remove a tuple from a relation. We'll include a where clause to select which records are to be deleted. Referential integrity should be enforced on this, and the records will be deleted from only one table at a time. A missing where clause specifies that all tuples are to be deleted, in which case the table becomes empty. The number of records deleted depends on the number of records in the table that satisfy the where clause. Here's an example of the delete command. We have delete from employee, where last name equals Brown. That will delete all of the complete records where the person has a last name of Brown. If we just say delete from employee, we'll effectively delete every single row in the table. Finally, the update statement is used to modify attribute values of one or more selected tuples. So say somebody changes their last name, we can update that last name. And we use a where clause to select which records we want to change. An additional set clause specifies the attributes to be modified and their new values. Each command modifies records in the same relation. And referential integrity, specified as part of the data definition language specification, is enforced. So here's an example: change the location and controlling department number of project number 10 to Bel Air and 5 respectively. We have update project, set p location equals Bel Air, dnum equals 5, where p number equals 10. Here are some other examples where we give all employees in the research department a 10% raise in salary. Update employee, set salary equals salary times 1.1, where dno in, and then we have a select query that actually figures out which department they're in. So we've introduced SQL, which is a comprehensive language for managing a relational database, seen how to use parts of data definition language, how to perform queries, updates, specify constraints, and views. We've seen how to create tables, how to specify constraints, how to perform simple retrieval queries, and how to perform database updates. From here, I strongly suggest looking at the practical examples in MySQL.